Hi everybody. Well, I just got back from my back ride and I'm about ready to do some math, but I don't really feel like going inside, so why don't we start the lesson this week out on the sidewalk? On the driveway, and we'll use some sidewalk chalk. Okay, the bike ride is all done. Before we head in to do our lessons, let's go ahead and practice reducing fractions. So we're going to start with this one. We have 3/9, and if we can think of a number bigger than 1 that'll go evenly into 9 and evenly into 3, we'll choose it. So we're going to start with the 9 because it's bigger, and we think of what number will go evenly into both of them. Well, 3 will go into 3 and into 9, so we'll divide the top by 3 and we'll divide the bottom by 3, and that's the same thing as dividing by 1. So 3 divided by 3 is 1. 9 divided by 3 is 3. So 3/9 is the same as 1/3. Let's try a harder one. So first of all, I want you to see if you can say that fraction. Hopefully you said 8/12. So what we're going to do is we're going to think of the biggest number that can go into both of them. It'd be nice if it was 8, but 8 won't go evenly into 12. So the next bigger number that goes into 8 is 4. 4 does go evenly into 12. So 4 is the biggest number that goes into 8 and into 12. So we're going to divide the top by 4. 8 divided by 4 is 2. And then 12 divided by 4 is 3. So 8/12 is the same as 2/3. Now let's suppose you didn't notice that 4 would work. Let's see what else you could do. So what a lot of students do, I don't like this because it's too much writing for me, is they think 8 and 12, those are both even numbers, so they'll go into 2. So 8 divided by 2 is 4, and 12 divided by 2 is 6. The problem with doing that is you're still not done, because 4 and 6 are even numbers, so they'll go into 2 again. So 4 divided by 2 is 2, and 6 divided by 2 is 3. So you still end up with 2/3 either way, but this one requires more steps. So the more you can think of a bigger number to do both of them evenly in 2, the better. Here's our last one. 14/21. That one's going to be tricky. So we're going to think of the biggest number that can go into 14 and into 21. And so you think about your times tables and you think of some. 2 doesn't work because 21's odd. 3 doesn't work because 14 doesn't go evenly into it. 4 doesn't work because 21's odd. 5 doesn't work because they're obviously not ending in 0 or 5. 6 doesn't work because 21's odd. 7 works. So 14 divided by 7 is 2. 21 divided by 7 is 3. So it's kind of weird to think, but 14/21 because it equals 2/3, and because 8/12 equal 2/3, 8/12 and 14/21 are actually the very same amount. Let's head in and we'll finish up the lessons inside. Hey everybody, just a couple of weeks left, about 3 weeks left of, actually just 2 weeks of homework left of 4th grade math. We have a lot to do to get you guys ready for 5th grade. So we're going to start with some pretty hard fraction stuff about common denominators, which we already practiced outside, and working some mixed problems. So anyway, I want everyone to kind of hang in there for today and just do your best. Keep practicing those multiplication and division problems, and let's get started. Okay, we're going to get started now. 2 of our 3 lessons this week are going to be about fractions, and this is super important. Matter of fact, when I teach algebra and geometry and algebra 2 in high school, one of the things that messes students up the most from all of their elementary years is fractions. So I especially want you to focus a lot on fractions. So I want to remind everybody of something that we did last week, and that's the idea of renaming fractions. So if we have a number like 2/3 and we want to rename it, then all we have to do is multiply it by something that's the same as 1. So 4/4 is the same as 1. So if we have 2 times 4 is 8, and 3 times 4 is 12. So since 4/4 is really 1, then 2/3 is going to be the same as 8/12, because anytime we multiply something by 1, we get the answer that's the same. So 2/3 and 8/12 are the very same thing. So we're going to take that information and we're going to extend it past that. So one of the things that's going to be super important, a concept that we're going to be doing, that you're going to be doing a lot in 5th and 6th grade, and even all the way through high school, is in order to add any two fractions or subtract any two fractions, you have to have something called a common denominator. Okay, so let's talk about the word common. If you think about what it means in real life, it just means something that that is around a lot. Like $1 bills are pretty common. $100 bills are uncommon, okay? So common often means just things being around. But you can also think about it in terms of, if I said, I like to swim, and if you like to swim too, you could say we have that in common. We have that the same because we both like to swim. One of the things that we have that you have in common with your classmates is you're all in 2nd grade math. So that's what common means. Common means two or more things that have something that's the same. So a common denominator is two fractions that have the same denominator. Just realized I didn't spell that very well. Okay, so I'm going to write some fractions on here. Oh, and just a reminder, the denominator is the bottom part of a fraction. So in this fraction, 8/12, 8's the numerator, 12's the denominator. So I'm going to write 3 fractions. Okay, so if you look at those 3 fractions, we have to decide which 2 fractions have a common denominator. So let's look at this one and this one first. So this one has the 3's in common, but that's a numerator, so it's not a common denominator. You have to look at the bottoms. So this is a denominator and this is a denominator. So 3/8 and 2/8 have a common denominator. So make sure you remember that definition. If it comes up like on a test, it won't of course this year, but for next year, if they're looking for common denominators, they want the bottom part of the fraction to match. Okay, so let's suppose we had 2 fractions. Let's suppose we had 2/3 and 3/4. And they wanted us to rename the fraction to an equivalent fraction that had a denominator of 12. Okay, so we know our 2/3 has to have a denominator of 12. And so what we're going to do is we got to figure out what goes here. So we know that this fraction has to be 1 to be an equivalent fraction. So we've got to think about 3 times something equal 12, and of course that's 4. And in order for this whole thing to be 1, we have to have a 4 on the top. So 2/3 is the same as 8/12. Now we're going to do the same thing to 3/4. Four times something equal 12, that's 3. If we're going to have 3 on the bottom, we got to have 3 on the top. So the equivalent fractions to 2/3 and 3/4 that have a common denominator of 12 are 8/12 and 9/12. That's kind of just doubling what you've done before. This next part is going to be trickier, and this will be one of the things that's going to really take some time getting used to in 5th grade. If you want to practice it over the summer, that would be great, but it also you'll get it retaught a little bit in 5th grade as well. Let's suppose we had 1/2 and 1/3. Okay, so we have those 2 fractions. They want them to have a common denominator, but the common denominator has to be, you have to figure out what that is. So what I always like to do is I always like to look at both denominators and I think about which one's bigger. The 3's bigger than the 2. So I'm going to write some multiples of 3. Remember, that's just your times tables. So I'm going to write 3, 6, 9, 12. That's probably enough. Actually, I don't even need that many. So when I do that, what I have to do is I have to go through all of my multiples of 3 until I find one that also works for the 2. So 3 doesn't work for 2, 6 does, okay? So that tells me that's going to be my common denominator. So now I'm going to do the same thing I did in the earlier problem. I have 1/2 times something equals something over 6. Okay, so I know 2 times 3 equals 6. Whatever I put on the bottom, I have to put on the top. So 1/2 is the same as 3/6. Now I'm going to do the same thing for 1/3. I know my common denominator has to be 6. So 3 times something equals 6. That's a 2. And since I'm multiplying by 1, I have to put a 2 on the top. So the common denominator, the renamed fractions that have a common denominator for 1/2 and 1/3 is going to be 3/6 and 2/6. So that's my final answer. Let's try a harder one. Let's suppose we had 1/7 and 4/21. Okay, so I'm going to look. The good news is we can do this one right from the beginning. If you think about that 21, that's the same as 3 times 7, right? So I don't even have to put in my other multiples of 21 because the very first one worked. So that means this one doesn't even have to change. So this one's going to be 4/21, and now I just have to do my 1/7. And 7 times 3 is 21, so I make it a 1. 1 times 3. So the renamed fractions for a common denominator of 21 are 4/21 and 3/21. We'll do one more and then we'll move on. Trying to keep a piece of paper underneath so I don't mark up my dining room table. Okay? So this time we'll do a harder one. Let's do 4, 6, and 1/9. Okay? So I look at the 6 and I look at the 9. The 9's bigger, so I'm going to write down my multiples. 1 times 9 is 9. 2 times 9 is 18. 3 times 9 is 27. I'm going to go ahead and stop there. Okay? So 9 doesn't work for the 6. 18 does work for the 6. That's my magic common denominator. So I have 4/6 times something over 18. Okay? So 6 times something equal 18. It's 3. Whatever you put on the bottom, you got to put on the top. So 4/6 is going to be the same as 12/18. This one you might be able to do in your head, but I'm going to go ahead and work it out. So I know 18 is my new common denominator. 9 times something equal 18. It's a 2. This has to be a 1. So if you were told to rename the fractions so they have a common denominator, the 4/6 would turn into 12/18, and the 1/9 would turn into 2/18. And that's how you do those. This next section, they make it seem like new, but we actually did these a few weeks ago. Because if you remember, every time we had to do rounding, I like to do ginormous numbers on you guys. And now we're going to learn about ginormous number rounding. So first of all, the hardest part, I think, of rounding is remembering what the ginormous numbers mean. So I'm going to write a problem here. Okay, so let's kind of talk about what all of these numbers are. First of all, you always have to start on this end. So this is easy. Ones place, tens place, hundreds place. And these are actually considered the ones. So it's 1, 1, 10, 1. So the 7 would be 7 10 ones, and the 9 would be 9 100s. Okay, this group here is the thousands group. So I want you to think about what this group of 3 is. You said millions, you're right. And then, do you remember what comes after millions? Billions. Okay, so we've got the ones group, the thousands group, the millions group, and the billions group. Okay, So in each group, it's the ones place, the tens place, and the hundreds place. The ones place, the tens place, and the hundreds place. The ones place. What do I mean by that? 1,000s place, 10,000s place, 100,000s place. 1 millions place, 10 millions place, 100 millions place. The 1 billions place. If I put some numbers here, I could put a 6 and a 1. This would be the 10 billions place, and this would be the 100 billions place. But we're big enough for now. Okay, so the trick is you have to figure out what place you're rounding to. So let's suppose we had to round this to the nearest 100,000. So if we're rounding it to the nearest 100,000, we've got to find the 100,000s place. So here are my thousands, 1,000s, 10,000s, 100,000s. So now I look at this one, and I have to look at this one and decide if I'm going to have to make this jump to a 7, if it's going to stay a 6. Since it's 4 or less, the 6 is going to stay a 6. So since it stays the same, everything before that I'm just going to recopy. I'm even going to leave the commas in. Now everything after that becomes a 0. 0, 0, 0, 0, 0. Okay? So 4,183,625,970 rounded to the nearest 100,000s place is 4,183,600,000. Okay, let's try another one. Okay, so we've got a number like that, and this time we're going to round it to the nearest 10,000s. Sorry about that, I got interrupted, so we'll have to start back up again. Okay, to the nearest 10,000s place, so I got to find it. These are my thousands, so it's 1,000s, 10,000s. So I'm rounding it to that spot. So I look at this one. It's 4 or less, so what that means is this number stays the same. So I'm just going to recopy everything that came before. And then everything after it is a 0. If it was already a 0, it just stays a 0. So 38,465,810,310 rounds to 38,465,810,000. Okay, this time, let's suppose we have, this will be our last one. Like I said, I think you guys are pretty good at these. Okay, this time we're going to round to the nearest 100 million. So we've got to find the 100 million spot. These are all the thousands. These are all the millions. 1 millions, 10 millions, 100 millions. Actually, let me change this number because I want it to be big. Okay, so this time it's 5 or more, so that means we round up. So the 6 is going to become a 7. Everything after it's going to be zeros. So I'm going to recopy the early numbers. My 6 becomes a 7. Those 2 become zeros. Then I have 3 more zeros and 3 more zeros. So 58,678,479,021 rounded to the nearest 100 millions place is 58,700,000,000. And that's it. Okay. I think, like I said, I think this will kind of be a welcome break from all the division and big multiplication and all the fraction stuff. So I think you guys will enjoy this lesson. And that's 2 lessons down. We only have 1 to go. Okay. And this last one is, a little bit of good news. We are skipping 118. It's some fairly complicated division, and it doesn't really make as much sense to practice this one when you won't get a chance to repeat it, and I think it's more important to focus on the fractions. So that's what we're going to do. So we're skipping 118, and we're ready to go to 119. So 119 is adding and subtracting fractions with different denominators. First of all, I want to practice, I know we did it, we've been doing it for a few weeks now, but I just want to make sure everybody remembers how to do it the old way. So if we have 3/7 plus 5/7. Okay, so if we have a problem like this, then what we would do, first of all, we got to make sure we have matching denominators. And now we have a name for that, common denominators. So they're both 7s. So if we have 3/7 and 5/7, we add the 3 and the 5 together and we get 8/7. Now, you'll notice that that's an improper fraction. We talked about that a few weeks ago. And if you have an improper fraction, you have to reduce it. And the way you do that is it's 8 divided by 7. And if you can do this in your head, that's fine. 8 will go into 7 one time. Remainder 1. So the answer becomes the whole number. The remainder becomes the numerator. And the denominator stays the same. So 8/7 is the same as 1 and 1/7. Okay, so that's all review. So what we're going to do now, this time what's going to happen is our two denominators are going to be different from each other. So let's see how that plays out. So we'll start off with a pretty easy one. Let's suppose we had 2/3 plus 1/9. Okay? So now we want to add them, but you can't add unless you have matching denominators. So see how we have a 3 and we have a 9? They have to be matching before we're allowed to add. So we're going to use the rule we learned in 116 just a few minutes ago to figure out how to do that. So first of all, we're going to see which one's bigger, which is the 9. And we know 1 times 9 is 9, and 2 times 9 is 18. We're going to stop there. We may not even need it. So if you look at that, you'll see that if you look at these, let's check them out in order, starting with the smallest. The 9 works for the 3. So that means that 9 is going to be our new common denominator. Since this one's already a 9, it doesn't even change. That's nice. So now we've got to focus on the 2/3. So we have 2/3, and we know we've got to get it to something over 9. So I'm kind of working this on the side so I can put it back in over here. We do this a lot in higher level math. So 3 times something equal 9. That's a 3. And if you can multiply the bottom by 3, you've got to multiply the top by 3, so it's 6. Now we know 2/3 and 6/9 are the same thing. 1/9 and 1/9 are the same thing. So now all we have to do is add. 6 plus 1 is 7. 7/9. Okay, let's try another one. Let's suppose we had, this one's going to be trickier. It looks like it would be easier because it looks like the numbers are easier, but it's not so much. So we're going to do 1/2 plus 1/3. So first of all, we'll see which one is bigger. That's the 3. And we're going to do multiples of 3 till we get one that works for 2. So 3 doesn't work because it doesn't work for 2. 1 times 3 is 3. 2 times 3 is 6. 6 does work for 2, so we can stop there. So we're going to change the 1/2. So we know 6 is going to be our new denominator. I'm going to go ahead and write it down. That way I don't have to remember it. So I know I need to know what fraction is going to be the same as 1/2 that's with 6. And I'm going to go ahead, I'm not going to work it on the side right now because I think you guys know how to work it on the side. But if you can think of it in your head without working it on the side, I'm okay with that. So 2 times 3 is 6. So 1 times 3 would also be 6. So 2 times 3 is 6. So if we're going to multiply that one by 3, we've got to multiply the top one by 3. And so 3/6 is the same as 1/2. Down here, 3 times 2 is 6. So if I'm going to multiply the bottom one by 2, I've got to multiply the top one by 2. 3/6 plus 2/6. 3 plus 2, well, first of all, they're a common denominator, so I know the denominator is going to stay the same. And 3 plus 2 is 5. Okay? It also works for subtracting. Let's suppose we had suppose we had 10/12 minus 1/2. Okay? So first of all, 12 is our bigger denominator, so we'll write 12. Now we know 12 is an even number, so it's going to work for the 2 as well. So we'll just keep the 10 12s, 10 12s. And we've got to change the 1/2 to a common denominator of 12. So I'll go ahead and write that down too. I always like to write them down first. So 2 times 6 is 12. 1 times 6 is 6. So since we have a common denominator, we know that's going to be our denominator of our answer. 10 minus 6 is 4. Now, this is something that's called reducing the fraction. We talked about it before. Every time you get an answer, when you add and subtract and multiply and divide fractions, you're always supposed to reduce it. So we know that 12 is a multiple of 4. So we know we can divide both the top and the bottom by 4. And 4 twelfths is going to be the same as 1/3. Now let's suppose you didn't notice that. You probably did notice that they were both even. And if they're both even, you can divide by 2. So 4 divided by 2 is 2. 12 divided by 2 is 6. But now they're both even again, so you got to divide by 2 again. So it takes a bit longer, but you can get there. Okay. We'll do one last one and then we'll call it a day. Okay. Let's suppose we had 3/4 plus 2/3. Okay, that's a big one. Okay, so we're looking at something like that. Get it down here so we can see it. So 3/4 plus 2/3. So first of all, 4 is our bigger one. So 1 times 4 is 4, but it doesn't work for 3. 2 times 4 is 8, also doesn't work for 3. 3 times 4 is 12. That does work for 3. So that tells us that our new denominator is 12. Okay? So now we've got to find equivalent fractions for each with the common denominator of 12. So 4 times 3 is 12. So if I'm going to multiply the bottom by 3 to get 12, I got to multiply the top by 3. 3 times 3 is 9. Okay? 3 times 4 is 12. So if I do 4 on the bottom, I got to do 4 on the top. 2 times 4 is 8. 9 plus 8 is 17. Okay, so notice it's an uncommon fraction, an improper fraction. So that means that we've got to divide. So we know that 17 divided by 12, even if you can't do that, you know that 12 twelfths is 1. So we'll put a 1 there. And then it's so 12 twelfths, and then we've got 13, 14, 15, 16, 17. So it's 1 and 5 twelfths. And that's how you do those. So you have to get common denominators. Then you have to add them or subtract them. And then after you do that, you have to look at the fraction and see if it can be changed to a mixed number or see if it can be reduced. And that's it. There's only one lesson left in the book, and we'll cover that next week. Bye for now.